you hear me okay? Here to show, I'm as a new postdoc at SAFE. My project is going to be, it is about studying Antarctic sea ice and atmospheric interactions. And we're planning to use ACCESS-S2 model. And as the first step, before running the experiment and burning KSU for nothing, the idea was to try to evaluate how well it actually represented Antarctic sea ice. So you might be saying why we might simulate or why do we care about Antarctic sea ice. It's just ice. But I think we had a bunch of talks already that showed that ice is important. But our main driving here is that sea ice and the sea that it sits on top of are very different surfaces. Like you can see here that sea ice has a very different albedo, has a very different roughness. It inhibits fluxes with the atmosphere. So it actually has, we think it has implications for atmospheric circulation. So for example, this is looking at the eddy geopotential height for July's, well, it's spring geopotential height for years with low sea ice concentration or high sea ice concentrations in July for two different models in the rows. And you see there's a signal there, although if we look at the difference, the signal between the models don't really agree of what the signal is. So clearly, we think there's a signal there, but we are not very sure of what the signal actually is. So clearly, we need more research, which is good for me. So let's talk about ACCESS-S2, which is not supported by ACCESS-NRI, so don't beat me up. So this is kind of the model configuration. This is a seasonal forecasting system by the Bureau. And this is basically what I want to highlight here. One of the differences, or key differences, at least for my point of view or for my research, is that for ACCESS-S2, they are not doing assimilating sea ice concentrations. It's kind of implied by a simulation of sea surface temperature kind of near the sea ice edge, but there's no sea concentration simulation. So we kind of expect that, we know that for as comparison with with ACCESS-S1, the previous iteration, let's say, the bias in sea ice concentrations, or at least in sea surface temperature, a high latitude actually is worse than ACCESS-S2. So we can expect that it's probably it's going to have a tough time actually simulating sea ice. So first, I'm going to go over to look at the reanalysis, and as a first headline figure number, looking at the sea ice extent, the seasonal cycle, which is for ACCESS-S2 in black here, and for NSIDC satellite-derived observational dataset in blue. And we see that there's a very, very huge underestimation of sea ice extent during the minimum. And then for the maximum, it's kind of fine, although it peaks early, and then it starts to melt early too. And of course, the growing season is also much faster than in the observations. So we know there's a bias there, and if we look at the spatial signature of the bias, it's what you would expect. That is, we have a negative sea ice concentration bias in those months that we had the negative sea ice extent bias. Basically, anywhere there's sea ice, ACCESS-S2 is simulated less sea ice than in the observations. And looking at the anomalies of removing the seasonal cycle, we see that it's kind of also not very good. We have, for ACCESS-S2, it's simulating a decrease in sea ice extent anomalies, which is quite common for models, which typically do not represent the slight increase up till 2016 or so. And we also have this like gigantic decay or reductions in sea ice extent, which we don't see in the observation. And it's like they are like larger than anything observed, basically. Also here around the 2010s, late 2000s, we also have these high values, which are wrong, but on the other hand, they're kind of like a good opportunity to see what's going on here and why is the model simulating these extreme anomalies. We also have the hindcast. So these are forecasts with 42 members up till 42 days, and then only 3 members, so that's why we have a different amount of lines. So this is as a function of lag, the root mean square error of the sea ice concentration anomalies. Lower is better. That's something I always need to think about. And if we compare with just a reference forecast of persistence, we see that on the median, we are not in a very good spot because we are always, no matter the lag, we are always worse than the persistence. So we are spending, running this model, and regarding sea ice, we are not better than just assuming that the observations carry forward without any change. So again, not a very good place to be in that sense. We can look at the seasonal evolution of that, and it's kind of, uniformly always worse, except we have some silver lining here. We can forecast sea ice concentration anomalies better than persistence for a few particular days of the year, which we can also look at it in the other way. So this is the median root mean square error for forecasts started at the 1st of every month, which are these colored lines, and the gray lines are the same, but for persistent. And basically, for February and March, basically, we are better than persistence even at large lags, which would be these green lines here. Of course, in the cold seasons, we are much worse, even at very, very low lags, so for example here. So although we have a high large bias, a large negative bias, sea ice extent during the summer, the warm season, or at least the anomalies seems to be easier to predict. And, well, it was a short talk. Okay, more time for questions. Thank you.
Thanks very much, Elio. So questions from the audience? Tom?
Yeah, thank you very much for the talk. This kind of grows too fast, melts too slow bias in climatology is pretty common in sea ice models in this context. Do you have any thoughts on what might be causing the bias, and could it be incoming radiation?
Sorry, can you repeat the last one, the last part?
Do you have any thoughts on what could be causing the bias, and could it be shortwave radiation?
Easy question to answer? I don't know. Not really, but I would be glad to talk to you if you have any ideas.
Thank you for the nice talk. I was interested in about the structure, the vertical structure of your sea ice. Does it have a lot of layers so it could spread out into the ocean and have a lot of area to melt, or is it?
The model uses this size model. I think it has around 8 layers, if I'm not mistaken. I don't know if the ACCESS-S2 configuration itself has that many layers.
So do you know if it's sensitive to how spread it is to the, so that it has a lot of area, it feels the ocean and melt?
No idea.
Thanks.
Yep, Andy.
Yeah, just wondering how much you can tell us about the initialization. Like, it seems that you decay away from persistence extremely quickly. So are you, does the model initialize well from the initial state when you're doing those hindcast forecasts?
No, it doesn't. So yeah, a large part of the problem is the initial conditions, we think. That's why, at least in the, for example, what is shown here in sea surface temperature, ACCESS-S1, which actually did include sea ice concentration and simulation, did a little bit better. We are going to compare this ACCESS-S1 with ACCESS-S2 and to see if the initial conditions actually, it's improving. And also, I'm not showing here, but if we look at the root mean square error here, and we try to look at that statistical relationship between the error in initial conditions and error in the forecast, there's a strong, naturally, of course, there's a strong linear relationship, a strong relationship. So I think improving so this kind of informs how to move forward with this seasonal prediction system. If we want to improve our predictions of sea ice concentrations, putting more effort into assimilating sea ice concentration data.